Let us evaluate the limit x tends to 0, e to the power x plus e to the power minus x minus 2 cos x divided by sine square x. So we want to evaluate this limit. Observe that as x tends to 0, e to the power x tends to 1, e to the power minus x also tends to 1, and 2 cos x tends to 2. So 2 minus 2 is 0, so numerator tends to 0. What about the denominator? As x tends to 0, sin x tends to 0, so sine square will also tend to 0. So it is of the 0 by 0 form. So if it is of the 0 by 0 form, then we can apply L'Hopital rule. So we apply L'Hopital rule and we differentiate the numerator as well as the denominator. Now we know that derivative of e to the power x is equal to e to the power x. Derivative of e to the power minus x is equal to minus of e to the power minus x. Derivative of cos x is minus sin x, so this is equal to plus 2 sin x. Derivative of sine square x is 2 sin x into cos x, that is sin 2x. Limit x tends to 0, we write as it is. Observe that as x tends to 0, e to the power x tends to 1, e to the power minus x tends to 1, 1 minus 1 is 0, and sin x tends to 0. So numerator is again of the type g, numerator tends to 0. What about the denominator? Denominator also tends to 0. So it is of the type 0 by 0 form, so we can apply L'Hopital rule once again. And this must be equal to limit x tends to 0. Of course, while applying L'Hopital rule, we must make sure that the limit exists. We assume that limit exists. Derivative of e to the power x is once again e to the power x. Derivative of e to the power minus x is minus of e to the power minus x. So derivative e to the power x is e to the power minus x times minus 1. Derivative sin x is cos x. What about the derivative of sin 2x? Sin 2x is 2 cos 2x. Okay, now as x tends to 0, denominator tends to 2. What about the numerator? Numerator e to the power 0 is 1 plus 1 plus 2 times cos 0, so that is 2. So that is 4 by 2, and that is simply equal to 2. So the given limit is exactly equal to 2. So this limit is exactly equal to 2 and it exists.